Welcome to the Unboxing Technology series by Digiterati. This video is on Kubernetes with microservices.
So before exactly learning about what is microservice, I hope we are all aware of the word called or the jargon called monolithic architecture. So microservice is actually, it's not a program or it's not something that we can code. So it's like a design pattern. Like, why am I trying to do a project with microservice as my design pattern or architecture way of working or splitting my project? So monolithic application is something which was used in olden days, where it is like an independent project. So it's like a self-contained. So it is not trying to get the data from multiple APIs or multiple projects. So if suppose when I take a banking project, for example, you as a Standard Chartered or as any company, you have all the modules that is required for your company to be hosted, that will be developed by your own internal developers. So we are not highly dependent on a third party. Like, for example, if I do for an online shopping nowadays, we use like login with Facebook, login with Gmail. We have many websites where they are not asking us to register. So if you are authorized by some other project or by some other application, web application, they are trying to directly give you a authorization for this particular site. That means that particular company does not own a login module. They are highly reliable or they are highly dependent on another project's authentication. Like, either they can be doing it through a JWT authentication or a bearer token, or the authentication methodologies might differ, but they do not have their own database or a particular way by which they are trying to provide an authentication for their users. So they are highly reliable on the other project. So that is one deviations or one something new topic, new concept that we are facing nowadays. So in a monolithic application, it was not like that. It's a single independent unit. It was not reliable or it was not depending on something else. And it describes a software application without modularity. So the main idea why we need microservice was modularity. So it's like one single deployable unit. Your monolithic applications was one single deployable unit. Whereas if I want to use only one part of the module in some other project, if I want to reuse my modules, so my company will be doing a project today, tomorrow they might be doing some other project, where if they feel that one component of the project which is already available and they want to reuse it, that was not possible. So they had to again develop the things from the scratch. So that is, modularity was missing in my monolithic applications. And it's a big container when all software components of an application are assembled together and they are tightly packed. So these where the features, or this is what is called a monolithic application. So as a gist, we could take that it is one single deployable unit. I could not break them, or it was not modularized. Okay. So to be precisely, we have taken okay. So before your microservice, so when we were talking about our monolithic architecture, so example is like when we get a HTTP request. So when a client asks for a Flipkart or any other kind of a site, okay, when a request is made, the server side application, so that means either through your JSPs or your Spring or your .NET side of ASP or MVC, through any other mode of server applications, we try to send the request. So the data is taken from the database, and then again the data is sent back with your logic being applied and given it back to your client. So all this is taken care by a single application. So nowhere I can plug in or I can share my data, get from this application, pass it. Example of in banking, like your credit card validations. there are some rules, like any 16-digit number. First rule for a credit card is like it should be 16-digit number. So you will have a business logic method which will try to check the number of digits in a credit card. So if at all a user enters only 12 digits, we authentically say that wrong, it's not even a credit card. Then only we go for checking whether it is a valid credit card, like that particular number is expired or not. So that is the second condition that we go. So there are some business logics that we are trying to apply on the data that we get from the user, and it is all done in a single monolithic application. We are not trying to get the data, pass it to a third party, check whether it is being validated, and then they returning a true. So that's not happening, is what we are trying to say in a monolithic application. So what are the challenges that we normally face? To an extent we have discussed, but still it's like large and complex application. So it's one application that is taking care of the complete project. So by which it's like slow development. If it is just a module, the duration with which I can develop a module is much, it's like parallelly we can work, and I can put a lot of parallel resources because they are independent modules. Like you do the credit card validation, you do your login, you do. So we have different teams where I can split my work and I can get the job done. Whereas if it is a single large and complex application, it's like I'm dependent on my previous modules for in order to work with my current module. And then your blocks continuous development. So when this particular monolithic application was not suitable for the methodology of agile, point number one, and your way of DevOps. So we will also see the difference between agile and DevOps, because these are some of the jargons that we commonly listen in the industry. So we will also explain like what is agile, what is DevOps quickly, not much of theory. Okay. And it's highly unreliable, because if one part doesn't work, then the rest of the parts also I cannot rely on them, because it's all single deployable unit. Okay. And it's inflexible. So when I want to just replace one of my module, like today I've got a new logic for my validations of credit cards or a loan feature, then it was not that easy for me to replace my newer version or newer feature with the older one. So it was not that flexible for my user, and it was unscalable. So whenever a new feature was to be added, then I have to plan in such a way that it is not affecting my current modules. So all these were challenges that people were facing before the invention of microservices. Okay. So with that idea in mind, we will get into something called what is microservice. Microservice in the sense it's a service. Service is something like any logic, any piece of code that can be reused. So I write it as a separate service. So whichever module wants it, I can just get the data. It will be transferring of data between the applications. So microservice is an architectural style. So I would highly reiterate that it is a architectural style. It's just a way of redesigning your code. So a lot of people think that microservice means it's a template that's available in either Java or .NET or in any other kind of, it's not a template. It's just a way of redesigning, an efficient, a better way of remodeling your project. It's restructuring your project. That structures an application as a collection of small autonomous services, and it's modeled around a business domain. So a particular, like it's a banking application or a healthcare sector or an online shopping. So we have various business domains for which I try to just split my modules. So I try to make each of them independent so that I can reuse them for similar environments. So it's not necessary for me to again start my work from the scratch. So it's like building blocks, so that tomorrow when I need to build another structure, I can just redesign them. Okay, so this is your microservice architecture. Like to an extent, they are all independent modules for a particular business. Okay. And in microservice architecture, each service is self-contained. That means whatever they need is like it's a complete deployable unit by itself. It's not like a function or a DLL which has to be called by another application. They are all self-contained. They can very well handle themselves, and they can give you it's a single deployable unit, okay, and implements a single business capability. So let's understand what is your architecture of microservice. Okay, so you have a client, maybe for identity provider authentication is done, and you have your various services. So maybe before getting into this, I will tell you your, okay, so let's assume that I have a, is my whiteboard shared?
Yes, visible.
Yeah, thank you. Okay, so let's assume that this is my microservice one, which is my customer microservice. Like whenever a new customer registers, okay, for registering of new microservice, I have a customer service. Then I have my, so after a customer registers, obviously he'll do a product, he'll like list of products will be shown, correct? So let's assume that I have a list of products. So list of products, microservice. And then once I show all my list of products, he should be given a option to add to cart, correct? So like he can see what are all the products available in a particular brand or particular domain, after which he should be given an option to order it. So add to cart will be my next microservice. Okay, I'm splitting my project into various microservices. So I have my add to cart. And then your payment. I'm not getting into the detailed of add to cart and all that. So after the product is added to the cart, they should be given an option to make a payment and then finally get the billing. So either check out and make the payment. Okay, so the next microservice will be like your payment module. Okay, and log out. So the final thing. So I'm not even talking about logging in or authentication or registering a new customer and all that. So it's a list of customers. So whenever a customer is logged in, his dashboard will be given, like what all he can do. He can edit his profile, he can log out, or he can view his cart. So when I talk about this itself, you have all sub microservices. Like you can have another, as a customer, he can, what are the things that he can do is like he can view his cart, the previous items view, the history can be viewed, correct? So when I create my project like list of microservices, normally what do you do? If in your monolithic application, the design pattern itself will be like you will have a flow in which the customer will log in. So there it is tightly bound. So when your session variable store that the username value, then after which you will try to check if the user session is not null, then you will go for his, it's the record of his whatever dashboards. So what his previous transactions, what are the items that he has ordered, what is the logistics, right? Currently, what is the status of his order? So in a real-time application, you have so many use cases that you can design it as a microservice so that we can reuse it. Point number one. The advantage is I can reuse it. This customer microservice can be reused for another project also. If it is like just the database will be different, the list of products, the, I mean, like if I have my own list of products, an API which is displaying the list of all electronic gadgets, any online shopping thing can show that, correct? For example, take your live IPL data. like your cricket scores. So we can check the cricket score in various sites. There is no one authenticated site that only you should log into this site to see the data. Any news channels, any other RSS feeds, there are a lot of other channels or ways by which I can fetch the current score of the cricket match. What do you think is happening? It's just a microservice. So they have created that particular part which is updating your current score or your share markets, your NSE or your gold rates. So there are some part where we need to just get the data, what is happening, the current data. So they update it as a microservice, which can be used, plugged into many projects. So any website through which you are fetching your cricket scores are nothing but the application which is just plugging in this reusable module. So obviously they will be having a share of cost, but still this company, like any company through which, like your channels, they are not designing a particular project to fetch the data from the database. So do you think all these particular online shopping sites, they will not have their own EF core or your Hibernate or any other way by which they will write an code, a piece of code to get connected to the data source? So they will try to use certain third-party modules like microservices, which will just provide them the list of products. Like if it is like all electronic gadgets, so it will just, an URL will be shared. Like if Samsung has updated some new products, they will give the URL. So that once my Amazon, see, just for example, I'm taking these sites. So if my Flipkart or my Myntra just pings the URL, the latest data that is updated in Samsung or Redmi or Apple or whatever it is, it will be shown to us. Okay. So this is how the applications interact with each other. So it is like the URL, the endpoints. When I hit my application, your Myntra would have been written in Java, or your Amazon would have been written in Python. So your applications can be from different languages, but the URL can be hit and the data can be consumed in a JSON format, so that it is compatible with all kind of your front ends. Okay, so let's again move back to the architecture. So I hope now whatever I'm trying to say is much clear. So we have some service. So here I'm trying to bring all these, like whatever I showed in my whiteboard as a list of products, add to cart. So these are all those microservices, each service. Okay. And these services can be modularized. So it's all like plug and play. Whenever I want, I can just pull this and the same service can be consumed by another application. They are not tightly bound. Point number one is they are loosely coupled. As and when I want, I can plug in, and if I don't want, I can just use some other a better service. If I feel that this service can be replaced with some other better service, yes, I can do it. And it's easy without affecting my current modules. And this in turn, one and the other advantage is one microservice can call other microservice and get the data. So that is, the layers can be to end depth level. Like the layer to which I can fetch the data or I can use my other microservices is like microservice A can call another internal microservice. So where my layer of abstraction to the client is highly taken care. Okay, so these are all the advantages of using microservice. And you will have a service discovery which will help you. So the place you can register your microservice. So let me just give you a gist about API gateway. But before that, let me just show you some of my microservices. I have used .NET, but I will definitely ensure what I'm trying to say. So let's assume that more or less it will be like Java, .NET, and I will ensure like every other infrastructure or mainframe people also understand. So here I'm having a class called product, like an entity. So obviously any product will have a product ID, product name, and price. Okay. So I'm just having the features or properties of it, and this is your dummy constructor or default constructor. And I have a constructor where I'm trying to pass data, accept from the user, and initialize my properties. And here I have my get products. So whenever I call my get products method, I'm sure that it will return me the list of products. So you have some values which I have statically initialized here. If we want, we can use entity framework core or your Hibernate in order to just fetch the data from the backend, and you can populate this get products. So the ultimate agenda is wherever I call my get products, I will get some data. Okay. The backend can be a MongoDB, or it can be a SQL server or Oracle or MySQL, whatever may be. The ultimate agenda is I have a method in my API. So I will be coming to the difference between what is API and what is the difference between microservice and API. But just to show you, this is a microservice. Okay. So get all data where product.get products. I'm calling my product class get products method, and just now we saw it will return a list of products. And then I'm just, so whenever I call my get all data method, where I'm trying to say that it should be called as get prod. So that's the URL endpoint in which I will ping. So let me just run this code and check whether if I call my get prod of wallpaper, I should be able to view my list of products. So this URL will be given to Myntra or Amazon or whatever online shopping sites, and they can render this data in whichever format, like in a card, they can bootstrap, they can use where they can just show the data in a card or pane or whatever it is. So I have my get prod. So I'm calling my microservice. So this will be hosted always in my IIS server or any kind of web app server. So which should give me the data. So let me just cross check. Okay. So I hope the data which I initialized, the pen and your eraser and pencil and all that. So this is like, assume it's like the URL which has to be called by Amazon or any online shopping site so that they get this data source. And then it's up to them to render it in whichever. Now you have got a collection. Then in a for each, they have to just loop through and print it in whichever format using Bootstrap or Angular or React. They can just show the data in whichever format. So just imagine the same is applicable for your weather forecast or your cricket score. So when I pitch a URL, when I pitch an endpoint, I will be getting the current score. So then it's all up to me how I want to render it and show it to my user. Okay. So now this URL, so this is a microservice. What I'm trying to say is list of products as per my whiteboard. I showed you there is a microservice which will display list of products. So that microservice URL I have got. Now I will try to consume this in another microservice. Like microservice to microservice is also possible, and calling a microservice from the end client also is possible. So I will just try to show you that also. So this wallpaper is running now, and I'm trying to call that wallpaper in my another example, which is another microservice. So this is also another microservice which is calling my API wallpaper get product. And I have given the base URL here, which is some port number, and that port number's API wallpaper get product. I'm trying to hit the microservice. So please understand that the moment I try to change the data of this source, so if I try to add one more data or 2-3 more products I have added to my current database I have started buying in my company, that will immediately affect this API, because the URL, the source from which I get the data is this. Okay, so this is how microservices, they are all individual modules. So now we can just cross check that. Here I have not applied any logic, I'm just consuming that microservice and I'm just showing it here. And I could have rendered it in a different, like Bootstrap I could have used, or Angular or React or PHP, anything I can use to render my data and show it to the user. So this is another microservice which is called my, what should be the URL for this, tags slash get all details. So that should be the URL. So let me check. So this should be like API slash tags slash get all details. So actually speaking, in this API or in this project, I never have any class or anything from which I populate the data. There is no products in the sense like this is a different products. It's nothing to do with the data which I'm showing it to you on the browser. So here what I'm consuming in my tags controller is I'm calling the data of wallpaper and displaying it. So are we clear, like what is a microservice? This is a single deployable unit. I can host it in my IIS. I can call this as a part of my final deployable unit. Correct? It's not that it's not a DLL where I need a hosting application to call this. Point number one. So now let's try to stop my wallpaper and add few more data to that and check whether it is being displayed in my Docker sample. That is another, the second microservice. So let me just try to add. So there is one more data which I've added. So now I modify the data. See, now I'm telling you, I stopped my application in order to do some changes in my project. Oh, so I have got my product 4, and I will also just refresh my Docker sample, get all details to get that 4. So whenever your cricket score is getting updated or a new product is added into your original database, what I mean by my original database is this application of mine, wallpaper. Just an example I've taken. So whenever the original data is updated into your API, it is reflecting in all your microservices or applications which are consuming it. Okay, without just a refresh is enough. And there are a lot of other techniques using your service bus and all, where you can just, you need not keep refreshing it. The data will be using a push architecture to automatically push whenever there is a change. So that is taken care by different environments. Like you can use a push architecture for it. Are we clear to an extent, like what is a microservice? So these are all the different services, and they can be consumed by another service or by end client. Okay. And before I talk about gateway, which I will definitely be doing, but I would also tell you the advantages and the features and APIs. Let us complete these points before getting into the gateway concept. So as discussed, the features of microservice was it was small. So I know what is the purpose for which I'm doing a microservice. It's very target oriented. It's very clear and it's very focused. It's loosely coupled. So as I was saying, if I had to replace my wallpaper API with some other kind of a microservice, yes, only I need to change the URL here. Like my Docker sample, instead of referring to my wallpaper, I need to refer to some other API. That's all. So it's easy for me to switch between vendors. I'm not tightly coupled to my vendors. I can keep changing. So if this vendor is not keeping all his product updated, he's not often updating his products, it's easy for me to switch to another vendor who is giving me a better offer in reality. Okay. And it is language neutral. As I was again telling you, here I'm consuming one .NET API in another .NET API. But I could very well call this URL in an Angular project or in a React project or in Java project, and it's just a RESTful API's URL. You can consume this in any of your front end. So it's language neutral. Whereas in a monolithic application, they are tightly bound. So it was not that easy for me to call or reuse that piece of code, a .NET code in Java or a Java code in Python, because it's like protocol. It's that particular language based, correct? And you have your bounded context. So the context is like, for what purpose am I doing? So it's easy for me to split it. I need not cover everything into a single module and then try to break my head with converting that into the respective domains. So the advantages is independent development. So if suppose my project manager today have told me that you are supposed to release your wallpaper API today, it's an independent module I can generate. So I can communicate the data to from the database, and I can just post it in my application. And similarly, when I talk about your continuous integration and continuous deployment, which we will be doing as a part of DevOps, your data can be independently deployed. Like today, I'm independently deploying my Docker sample API and your wallpaper API. So they are independently deployed in my IaaS, in my app server. And fault isolation, as I told, if there is an error, if at all there is an error in one of the microservices, it will definitely not affect the others. And it's easy where I can just replace that API with something else, the URL with something else. So it is fault isolation. It's easy for me to just remove the fault module and mix a technology stack. So you can use any of this. Like I can use a Docker to create an image. I can use my Azure or AWS to deploy my this particular microservice. I can create it with Angular. I can consume the data in Angular, or MySQL can be your backend. So normally we use that SQL server is compatible with your .NET projects. So if I have to have the data from my data source of SQL and display in Angular, is it possible? Is it that compatible? Or a Java's Oracle backend or a MySQL backend data has to be displayed in Microsoft .NET. So now we need not bother about all this, because the data is just a URL for me. I need not even know the data sources like MongoDB, or it is a MySQL, or it is Oracle. I'm not even bothered. For me, it's just a URL. And if I consume that URL, my collection will be filled with whatever may be your collection, like a hash table or a dictionary or your maps or anything. It's filled with some data. And my job is to just loop through the data and display it to my user in whatever format I want. Okay. So, and granular scaling, I can easily upgrade. Like for example, tomorrow I have an option of my wallpaper API. Now instead of products, I want to get list of customers or list of something else. It's easy for me to just scale it up, because it's granular. Only that module I'm trying to scale it up. Imagine if the project has to be scaled up, then it involves more time, it involves more resource, it involves more planning. Whereas if I'm just bothered about only one of my module to be scalable or to be expandable, it's easy for me to plan. The cost will be low, the resource can be easily handled. So these are all the advantages of using microservices. Okay. Understand what are APIs, and I'll also tell you about gateway a bit later. First, let's understand what are APIs. So APIs are nothing but an application program interface. which are most commonly known as your APIs, and it's a way through which you can make sure two or more applications communicate with each other to process the client request. So an API can communicate with my service one. That is, let's assume this service one is my customer service, product service, cart to add to cart service, and so on and so forth. So when I try to actually get the data, so I can communicate among multiple APIs. Okay, so it's just an interface through which the data is transferred among multiple services. Or maybe how are APIs implemented? APIs are implemented through the RESTful services. So here, let's assume that I take an entity called customer, or I take an entity called a product. What are all the things that I can do with my product? So let's take my so let's take a product as an entity. Okay, so let's take an entity called product. What are all the things I can do with the product? Like if suppose I have a table, like in backend people will call it as a table, and your relation, and your front end people might call it as a class. So that's the underlying concept of your ORM, that is your object relation mapping, where I'm trying to map a table to your class in the front end. So what are all the operations that I can do with the product? Point number one is I can just One is I can add a new product. Point number two is I can update my product, like the price or the quantity or whatever may be the expiry date or whatever may be related to that, I can modify. And then I can select that product, like read and get the data. Select the product and fetch the data to the customer, like get. Okay. And the last one is delete the product. Like if no more that product is there in the market, I can just remove it off. Like a customer, an employee of a company, whenever a new employee joins my company, I can add them, or I can modify his phone numbers or years of experience. Then I can fetch the list of my employees, my company's employees, to the user, and finally I can delete that particular employee once he leaves my organization. So ultimately, if you take any entity, a customer, an account in a bank, what we can do, we can add, whenever a new customer adds to your account, you are adding a new customer ID and the account, the transaction table, you are trying to add an account. Then what are we doing? We are trying to modify his data, like withdrawal and deposits and all that. So whenever he's taking a loan, we are trying to add a record. And if you take a loan entity, also adding a record, modifying his loan amount, and fetching his current loan details to whenever he wants to see the data to his dashboard. And finally, all his loan is completely paid. Maybe it's not a hard delete. We will not completely do a shift delete. That is hard delete in the sense the data can't be tracked. So nowhere we will do a hard delete. We might do a soft delete. That means we might have a Boolean value like true or false, like active or inactive. So now if the loan is completed, or like paid, or now it's currently in progress. So something like a Boolean value we will have, and we will try to select only those records where the loan is currently active or the employees are currently active. Okay. So if you take any entity, ultimately you can do only these four operations with them. And then modification is like whenever he is withdrawing amount, we will try to subtract his value. So again, an update. So throughout the project, we will be doing only these four operations with any entity is what I'm trying to say. So keeping that in mind, your HTTP methods. So we call this RESTful is nothing but representation of state transfer. That is what we call it as REST. So REST API is nothing but representation of state transfer. That means the state of this entity called product or loan or customer or anything is getting changed. So first it will be added, newly added record. Then it will be modified record. Then it will be detached record or deleted record. If it's a hard delete, we call it as deleted record. If it's soft delete, we call it as detached record. And this is my fetching all the list of customers, the list of products, the list of users. So this is just my selecting, reading the data from the database and giving it to the user for his viewing purpose, like account balance, all the transactions that you have done. Mostly the transactions tables will be the tables which I select in order to show it to the user. So keeping this in mind, we have used a CRUD. So any CRUD operation or crude operation, however you call it, we try to create a record. That is nothing but adding a new employee or adding a new customer and all that, which we do it through a word or a HTTP verb called post. So whenever I use a word post, that means a record is being added. Whenever I use the word put, then the record is getting updated. And whenever I say get, I'm trying to fetch the records from the database and show it to the user. And whenever I use the word delete, I'm trying to delete the record. These are the 4 HTTP verbs that is used in any API. Okay, whether it is in Java, we call it as RESTful API. In .NET, we call it as web APIs. So only the jargons or the templates will be different, but both of them will be using your get, put, post, and delete. These are your 4 HTTP verbs that we will be using in order to represent the state transfer of a representation of your state transfer. So whether the record is getting newly added or modified or deleted, what is the state of that particular record? So to get that, we use it. So now again, revisiting my same wallpaper or my same Docker sample, let's again revisit the same. I have a HTTP get. The get method means I'm trying to take all the list of my data and give it. Here I don't have my post and put. Maybe I should have it here. Okay. Okay. No problem. So we have only the get. I can just show you one sample API. If given time, I can create it and show it to you, or I can at least open my some of the projects which has all this. Okay. So here I can show you the complete. So here I'm dealing with my employees. Okay, so here I have my context from which I'm populating my employees. So here I have my get method, HTTP get. So as we have discussed, get is to select the list of employees. So it's like I'm fetching the data from the database and giving it to the user. Then you have your get by ID. That means instead of all the employees, I want to pass the ID of that employee and get the data. And then you have your put. Okay. So the put here is what is important. This is just any name you can have, but the HTTP put says I'm trying to modify the employee. So the ID, for whom am I modifying? The latest data is of whom. So I'm just checking that. So the put is also here, and then your post. Whenever I want to add a new record, then I will just try to have a post. And finally, I will have a delete where I'm trying to pass the ID and remove that record from my database. So roughly speaking, whether it is Java or .NET, generally speaking, it's like you have your HTTP verbs of delete, post, put, and your get. Ultimately, these are the 4 operations I can do with an entity. Here I'm dealing with employee. You can do the same with product or loan or account or anything. So this is an API. So API is nothing but a RESTful, representing the state of a particular entity. Okay, which is like a template, which is like a project or a coding that we have to do. But microservices are just the architectural style. I'm trying to restructure my code. So that's the difference. API is a code and it's like a template that I have to choose in order to project my data, the state transfer of my data, so that I can project this URLs. So when I run the code, I will be getting a URL, like as I have done it for my wallpaper API and my Docker sample API. So here these are, so this is for get all details. Like similarly, I can have a create a new record or edit a record or delete a record. So these are the URLs of my APIs. So now coming back to this, my APIs are nothing but they are some templates which makes multiple applications to be interacted. So the difference between my microservice and API, because a lot of people get confused. API is a template, whereas microservice is just a design pattern, an architectural style of modifying or restructuring your application. It's not a coding. I don't find any template like microservice. So it's an architectural style through which you can build applications in the form of small autonomous services, whereas this is a set of procedures and functions. So we write codes, we write functions, which allow the consumer to use the underlying service. So I write a code, I host an application, I consume it in another application. So that is API. Okay. So are we clear? So the final, this is what I was just making you searching for it. So you have your how API is used in microservice. So we have seen 2 different things. One is your API, one is your microservice. How are they both used together is you have your client browser, that is like us, we are requesting for Amazon or Flipkart or Myntra or any site. So they invoke your APIs, and your APIs, which in turn, your APIs are nothing but the URLs, exact hosted URLs. But internally, the design pattern will be like I have split this into customer microservice, product microservice, cart microservice, payment module, and so on and so forth. So this in turn will fetch the list of customers, edit the list of customers. So the CRUD operation for a customer is done through this microservice. And your products, CRUD of a product is done through this, and your CRUD of a cart. I can add a new cart, I can add an element in a cart, I can delete the element in the cart, I can modify the element, like instead of 5, I can change the item, number of items to 3. And I can fetch my cart history, like what are all the items I have already ordered. So that is done through this API. But since I'm not writing everything together in a single project, if I write everything together in a single project, what will be the disadvantage? Like it will become a single deployable unit. So when I host them in the application in the IaaS or in my Tomcat, they are closely bound. So if I have to modify one of my microservice without disturbing the other microservice, that is not possible. I have to stop my hosting. Then only I can edit. Imagine for 1 minute, your any bank sites are stopped. Imagine, so during that millisecond or that second or that minute, if any transaction is happening, what will happen to the consistency and the durability of the data? So even after this COVID scenario, we got our Gmeet, which is one of the new feature that is available in Gmail. But we have not even felt that the Gmail server was stopped for a single minute. So there is a method by which, without affecting my running application, I can do some modifications. I can add my new features. So with this current scenario, microservice plays a very, very, very important role. See, when I talk about a microservice, here, if I would have written my wallpaper, Docker, everything into a single project, the place where I'm going to consume, like here I'm calling my tags. That means what I'm trying to do here is my wallpaper is consumed in Docker. My Docker, like just for the, I'm talking about the project name. Okay, nothing to do with the Docker name here. So this API is consumed in this API and this API is consumed in your client. So here I'm trying to call my tags. So when I call my, this is my end client, an MVC client in which I'm trying to consume my data. So an API is like a template. Whenever I'm trying to create a new project, I will get a API as one of my templates. So here I'm displaying it in a console application. So this is an end client. So what is the ultimate data that I'm showing it here, which I received from my original API called wallpaper, which is again done with some modifications. I can apply some business logics in my second API, and that is what I'm consuming in my final client. So this is an example where I can consume one API in another API, and I can also consume one API in a client. In fact, APIs are the codes. Like for example, when I create a new project, I will be given a template whether I want to create an API. Whereas microservice is like a design pattern. For example, if you're trying to build a house, so you have some square feet of land. You're trying to just create one big hall. That is a monolithic application. Whereas when you try to just build a small room, and whenever required, you can build another room. So the cost for which you need to build just room by room, that is much affordable. Point number one, it can be easily managed, and the amount and time, the amount of time that's required to build a room is much more easier instead of building the entire application, which is tightly bound. Okay, so that is what we are trying to say. Microservice is just the pattern. It's a design pattern. There is no template as such, like I can choose. For example, here I go for an ASP.NET Core Web application. And just quickly, I'll create something like just I wanted to show you the template of Web API. See here, I am given an option whether I want to create it as a RESTful HTTP service. So we spoke about RESTful, which is like the representing the state transfer of your verbs through your HTTP verbs. So here I am given an option, and this is the symbol or the logo of API. That means it's like a Fixobricks. It's like a pluggable point. I can call this from wherever I want. Whereas I'm not given an option to create a microservice here. So microservice is nothing but, see, I can design a microservice. I can decide that my project has to be done like customer service separately, product service separately, add to cart service separately.
But the point is, I could have done it using my WCF also. I could have done it using my web services, or through, there are multiple options through which I can do my pluggable modules. But API is one among them. So I hope now I'm making you clear. Microservice is a design pattern which can be achieved even through a web service, through a WCF, through the API, through your DLL. There are a lot of ways in which I can bring modularity or granularity to my project. That is microservice. I want the entire project to be split into various small modules. That's a design pattern. Whereas API is like, how are we going to implement that? So one way of implementing your microservice is API. Are we clear? Here I have one microservice like product API, another microservice called user API. Okay. So, and I have just used these two. So to the end user, he cannot remember multiple APIs. Just imagine that my wallpaper is having a HTTP localhost, some URL. Okay. So when I tell my user that if you want to get the list of products, this is the URL which you have to remember. So he should not be known about multiple URLs at all. So for which what we can do is we can follow a gateway pattern. Gateway pattern in the sense the user will not know. The user in the sense here, who is the exact user, the person who is going to consume my API. Like for Cricket Score API, a news channel is a client, and we are the ultimate end client who is going to view the news channel in order to know the score of a match. So I'm not talking about the end client. I'm talking about the customer who is going to consume my API. Okay, so for them, they cannot keep targeting multiple URLs, multiple endpoints. So for them, I will give a single endpoint and I will reroute internally in my project. So let me just show you. So when I hit product and get product, the same port number, when I hit product and get product, I'm getting my Alexa, which is the list of products. The same URL where when I say user/get user, I will get my list of users. So here it's not like my wallpaper and all that. It's not like my multiple tabs which I switched or multiple IIS in which it's hosted. Here, both my get user and my get products are hosted in the same port number. So the user will not switch between various port numbers or various URLs, but internally I will use a gateway where I would have rerouted it. So I'm using my reroute concepts here, where if the user hits this URL and if he is asking for this endpoint, then please set the server as this, the port number as this, and if he hits this endpoint, please use the port number as this. So these port numbers are not exposed to my end client. He will not know. Okay, so I think the agenda of the first few topics are clear, like what is monolithic application, what is microservices, why we need, what are their features, what are their advantages, what is an API, how it's been different from microservice, or actually what is the difference between an API and a microservice, and what is an API, how is it the representation of the state of a particular entity is being represented, and we have seen the samples of multiple APIs, how to host them in IaaS, and how do we deploy APIs, implementing your microservice architecture. Okay, and we have also seen what is a gateway. So the next topic where we are slowly moving towards our Kubernetes and DevOps and all that. Okay. So directly, as I said, we cannot pitch on Kubernetes. So I have to gradually take you through certain topics, which is like DevOps, images, Dockers, containerization, and then move towards your Kubernetes and how to host your application in your AKS.
which is Azure Kubernetes service. So according to us, what is DevOps? So DevOps is something like, we have to understand one point, that the project at any point of time, once I have brought it into a production server or online, like my customers have started using it, now there is no way by which I can unhost my application, which will have a direct impact on my end client. That cannot be done. But at the same time, we can't wait till the complete project is getting ready, and only then there will be no such day. Every day there will be some prospects of upgrading or revising or adding a new feature or some change request. So we have to face all this in reality. We can't wait for one idle day where the complete project is done and only then I will start my company or I will host my application. That fine day will never come. So there should be one technique by which I should not disturb my live application, but at the same time I have to keep pushing my upgrades, updates, and all the features and all that. So that is the necessity, or that's the place where we got this evolving process of DevOps. Okay. And DevOps also plays a very important role. Like, since we are all developers and we are all a part of a company, it will be highly apt for us to understand that the developers and the operations team should go hand in hand in order for a smooth deployment of a project. So the blame game should not keep continuing, that the project was ready but it was not properly deployed, or I properly deployed where the project was not up to the mark. So we have to have an efficient way of a smooth execution between these two people, and that's where DevOps forms a role. So quickly, I'll just tell you, before DevOps, obviously, I hope you people know that we were using something called a waterfall model, where the data was, so first it was the requirement was gathered and the specifications. We used to check whether it is feasible for us to create this project within the stipulated time, with this cost, with this resource, all the current resources which I have, all that will be analyzed, and then the design will be done, which is a high level design and a low level design. A granular design can be done, and then the coding. So if you ask about where API falls in, API will come in the coding part, whereas microservices will come in your design part. So here itself, I'll design whether my project should be done as a microservice or a monolithic application. Whereas how do you implement microservice is your API. Okay. And then going to your unit testing. So as and when I do a piece of code, I have to test it. And then I have to do an integration testing, where we have to talk about how multiple users' source code is being integrated, where we are being introduced to a new concept called source version control. Okay, through GitHub, how are we to integrate other users? And then we go for our system testing. After integration, if everything works fine, then your system testing, and finally your UAT, which is user acceptance testing, and then only we deploy our project. So all these phases has to be done in order to see the final deployable unit. Whereas, and if there is a feedback or if there is an error, again, it will be like all these. So the end client will be viewing my application only after the final stage. So getting a feedback after everything is done doesn't meet the requirement. So that's the reason we are moving slowly into the concept of agile. And I think in every organization nowadays, agile plays a very, very important role. So can anyone just let us know that, are we clear about the difference between agile and DevOps, or what is agile, what is DevOps? So as a gist, I would just quickly tell you that If I have a client, whether that means he's the owner of the product. Sometimes it is a B2B. That means one of the business will be a client for another business. So it's a B2B client in that he's the one client, one company will be acting as a client. Whereas like if we are going for some end user, like your mobile phones are coming, so your Apple iPhones are coming. So in that case, we are the customer, we are the product owners. So we will give the features. So we will say what are the best features. So they used to take the customer feedback by which they'll do your modifications, the change requests, the new features are introduced. So what the customer needs. So as a feedback we provide by which they try to implement that as a part of their next requirement. So the gap between the development team and the tester team and the user, the client or the user is your agile. That part is taken care by agile. But after the code is perfect, after the code is all done, how do we deploy it to the user? How do we make it available to the user? How the project becomes live? That is done by your DevOps team. So the developers and the operations team is your DevOps. And how they go hand in hand, how the process is automated. Because if you see in DevOps, there are so many tools that's been introduced in the market. So we have our Git, our Zira, your Gradle, your JUnit, Selenium, your Jenkins, Docker, Chef, Ansible, Splunk. These are all your various third-party softwares which has been introduced. But only advantage is like they are free of cost. Whereas if you go for Azure or AWS, it's all these can be replaced with one go. But the point is the cost is involved. So you need not use a separate Jenkins to build a pipeline or a separate Docker to do containerizing your application. So all these are not required explicitly. They are taken care as one whole module as Azure or Google Cloud or AWS, or you have various other used. IBM also has a cloud, but predominantly we use our AWS, which is most flexible, and the next is Azure. Azure is actually, in fact, more flexible than AWS, but obviously it's very, very costlier because it's a product of Microsoft. Okay. So let's understand the stages of DevOps. You first plan your code, like what is that you need. Okay, so the design, till the design phase of your waterfall model comes here, after which the code is done. And for integrating your code, so we all know that in a real time, the code or the project can't be done by a single person. So when multiple developers try to integrate their code, they sometimes use SVN, which is very old technique of integrating, or then they use your TFS if it's .NET or Team Foundation Server, which is a single server where the codes are integrated. So that had a disadvantage where if the code goes wrong or if the server goes wrong, if for one day if the server is not working, what happens? We all lost our code. So that's the reason we went for some distributed way of codes. So GitHubs and Git played a very important role, and still it's playing a very important role. And Git is bought by Microsoft, so now it's an internal tool or product of Microsoft. So we have the code which has been integrated through Git. Then we try to build your code. So when I say by build, obviously all your dependency files and all your base frameworks that's necessary for my code to deploy, they're necessary for my code to execute, that will all be linked, and the code is checked for compilation errors and it's built. And then you go for your unit testing, whether you can use JUnit or Selenium to test your UIs and your codes, business logics. And testing is done, after which it's been integrated through Jenkins. and your deployable piece of code is being deployed onto your server, whether it is Jenkins server or your Azure server or AWS server, and then you try to operate. So here we talk about our three servers, which is our development server, staging server, and production server. When the code is in the development stage, so I can even show you that. Uh, so here you have a statement called if environment is development. So you have if environment is development, if environment is production, or if environment is staging. Your development is like the place, like your company. If you're doing a project, for example, if you are doing a project from your company to another company, the client. So the development server, obviously, if you are doing for Standard Chartered, then it will be like you will have your own development servers and production servers. Whereas if it's like maybe let's take company A is doing a project for company B. So company A, the place where the developers sit and work and the project is integrated and they try to check their codes after integration is your development server. And then they will try to reproduce or reconfigure the same setup in a staging server. So staging services, you can check whether my project works fine in a Linux environment. Is it working fine in a Windows environment, or is it working fine in a Apple environment or Macintosh? Because we don't know, the end customer the request might come from any kind of OS or any kind of browsers. So we try to check or by replicating the environments. Okay, so that is the need. Before giving it to the end client, I do all kind of testing. So that is what is your product staging server, the test servers. And finally, I go for my production server, which is my company B's server. So that is where the live customers, the product is in live. So that is where the customer's URL is being pinged and they are trying to fetch the data. So as and when I do a new feature enhancement, I will first check it in my server, which is my development server. Then I'll try to put it into my staging server. And finally, if everything is working fine, that's the place where I try to integrate a continuous deployment is being done in your production server. Are we clear? Like the terms till now, whatever I have used, like what is DevOps, the operations team, the development team, and what is Agile, the gap between the customer and your developers is built through Agile or filled through Agile, and your gap between your developers and testers and your operations team is done through DevOps team. And the slide of what are all the things that are there as a part of DevOps. Okay, and what are the various servers for you, where I have pushed my codes. Whatever I have in my local system, I can push my codes in a different place. Okay, so here there are multiple views of seeing a GitHub. One is it can be seen as a repository of codes. So it's just seen as a repository of all the codes, or there can be some projects out of which is still getting integrated. Like for example, so this particular project is being done by two different developers. Okay, and they are still pushing the codes. So it's like a place where developer 1 can do his code and push it, and developer 2 can do his code and push it. Now, this guy's code will work fine in his local system, and the next guy's code will work fine in his local system. But there is a possibility when both of them try to push their codes into a common server, we need to check it whether it is working or not. And that is where your Jenkins all plays a role. But as of now, see, Jenkins is a server which will check or your build your code after integration. Okay, and your Azure is also going to do the same. Your AWS is also going to do the same. I am responsible for my code to work till the time it's there in my system. But once everything has been integrated, we need a common server in which it's been checked. Okay, so that is what is your CI/CD is going to do. So in your GitHub, I can create a new repository and I can invite people. For example, let me create a new repository and I'll try to push a code right in front of you. So this is my URL. Okay, I can share this with anybody so that they can start pushing into my repo. So what are the steps which I need to do for that? Let's open any project, or maybe like I'll have some files. So let me create your So first, let me have, see, the advantage of Git is it's not only for .NET project or Java project. Yes, it's also possible, but what I'm meaning to say is I can even push or share my other like notepads or PPTs or anything. Okay, so I should give a Git in it, and the command prompts are much easier than to use with your Eclipse or your Visual Studio, because once I switch across multiple languages, then I should not be paralyzed by just not knowing the commands. So I should be flexible with my commands so that whether it is Angular or .NET or Java, irrespective of the code, I can just work with that. So these are the commands which I will also share it with you. But right now, let me push my codes here. So I'm setting that this particular folder's data should be available in this, and I'm adding all the, before that, let me check what are the files which are untracked. So these are the files which are there in this folder, which I'm trying to add it. And okay, so I have all these open. So maybe for a moment, I'll just close it. This commit message plays a very, very important role. So after which I'm trying to push it. Just give me a minute. sorry. So now, so the code is pushed into the server. Now let me just refresh this sample application. So, and check whether my slides, PPT, and my TXT is being added. Okay. So this is the way by which you can now, I can ask any of you to type it in my text pad. So let's do that. If you can share me your mail IDs, anyone, just for sample Gmail or any Prakash you can give me, or anyone can give me in the chat window, so that you can, I can make this code available to you and we can integrate. We both, or both our texts can be edited at the same time and it can be integrated. Am I audible?
Yes, you got one mail ID.
Okay. Um, okay. So I'm just inviting this person. So you can check your mail ID, sir. There will be an option to accept. So now pending invite. Okay. So he once Mr. Suresh accepts it, he will become a collaborator of my project. So he can edit my notepad and you can just type something like Mr. Suresh text, so that multiple people can edit with the same data. So you can check your Gmail and you can, so he'll become a collaborator once he accepts. Have you got the mail, sir? Okay. Okay, maybe. It's my own account. So this is how like it would have happened. So now if I go to the repository, who can access? So, okay, he has become a collaborator now. Still it shows pending invite. I think the response, we have accepted the invite, but still. But I think he has clicked on the, so now he has become. So now, Mr. Suresh, you can try editing the record, editing the file, any of the files, whether it is a PPT or a text, and I can open that here and show it to the user if you feel. See, the .git folder will get created. Previously, it was not there, and now it will get created. So this is called my local repository. So to just make you understand what is local repository and what is distributed repository. So we have our centralized version where your SVN or TFS works like this. So where you are trying to have a working copy. So that is your current Notepad or Visual Studio project or Eclipse project. That's your current working copy. And from your working copy, you're directly giving a commit to this TFS server or SVN server. So this is just an IP address. So if at all the server goes down, I will have only my working copy, he will have his working copy, and somebody will have their working copy. But if suppose something goes wrong to this repository, then I cannot be up to date with my peers. That's a disadvantage of using a centralized version control system. Whereas if I go for my GitHub, which is a distributed version control system, this is my working copy. That's my Notepad or some project. Okay. So here I am working, here two of my peers are working. So they will have an updated version in their local Git. What do I mean by local Git? I showed you a folder of .git. So that acts like a local server to me where I will get the remaining peers data into that whenever I do a pull from the repository. So in fact, how the flow goes is I can type my code, I can commit my code. You remember I would have typed git add dot and then git commit. So whenever I try to commit my code, the data gets pushed into this repository of my local Git. And then when I give a Git push, the data gets transferred from my local Git to my GitHub. Now, once the data is available in my GitHub, any other peers of mine can pull the data. And that will have a repository in their local Git. So even if my server goes down, which is not possible because my GitHub will have lakhs and lakhs of backup in my cloud. So even if one of my AZ goes down, that my available zones goes down, I can pitch the data from another GitHub server. But still, even after that, if I'm not able to take the data, then I can just ask my peer to push his copy, which in turn can be available in all of ours. So this is nothing but my local Git, and this is my GitHub. So in a distributed version control system, the backup is available from any of the local Gits. And your push and pull will help you to be up to date with your GitHub and Git. And your commit is to update your local Git from your working copy. So using the commands of git add, git commit, and git push, I'm trying to push the code from my working copy to my local Git to my repository. When I talk about repository, it's my GitHub. Similarly, vice versa, when I try to pull the data, it's from the repository to my local Git to my working copy. Are we clear? Like what are we doing in Git and what is Git? The purpose, like crisp. Just to give you an idea, I'm just going through this. So any doubts if you have, you can just ping me. Okay, he has done, edited, and committed the changes. Perfect. So you should also push the change. So apart from committing the change, it would be good if you push the change also. Let's check. And we will get the history, like who did it, what was the change and all that. So it's saying updated 2 minutes ago. That means Mr. Suresh has pushed his data because 2 minutes before 2 minutes, we didn't touch this. And PPT and Notepad added and update So this was the initial commit message, but now, and it's saying that who made that update. So this is how your GitHub, which is, so now he would have added some text here. So edited by so and so. So this is what, now I can pull this code. Like for example, now how do I do it is, if I open my data here, it won't have his because I've not pulled. So what I can do is git pull origin master. Origin is your local Git and master is your GitHub. From there it will try to pull and see the name of the file, 3 insertions. So now I have pulled and I can open my. So I'm getting the data that's edited by someone else. Similarly, if I have 5 collaborators or 10 collaborators or hundreds or thousands of collaborators for a project, so it's like mutual. We took a Notepad example because it will be easy for all of us. Similar thing can be done with Eclipse, like a Java project, .NET project, anything, Python, PHP, anything, Excel sheet. Okay, so we should precisely understand that GitHub is a repository of codes which we mutually can edit, and I can see the changes which is made by my peers. This is the way by which my source code version control is being done, and I can have a track on the versions, like who did the change, what was the change, when was it done, how many commits have happened. So till now there are 2 commits which has happened. So one will be the first commit which I did. So PPT and Notepad added, which is the first commit, how many minutes ago, who did it. And similarly, what was the next commit data and who did it, how many minutes ago. So by which nobody can, like, we are completely responsible for the changes what we do and push it into the live server. So we can't play, and everyone is responsible, and the junior developers who are very fresh to the projects will, their codes will be reviewed by their senior developers in order to do the commit. Okay, so because you can decide on the people who can access your codes, who are your collaborators. So the commit IDs, we will be using this majorly in our build and release pipeline. So we can decide till where I have to build. If I feel that maybe still it's not up to date, then I can just build only to this commit ID. That means his change will not be deployed in the final deployment. So this is how, without affecting a live project, I can push my changes. Because if you feel this feature, this module is still not complete, I can keep deploying this commit ID. So these are all like step by step, the process gets clear, by which the deployment is unaffected by the changes. So to an extent it's automated, but we can decide till what level it has to be deployed. So it's not a completely automated process, but it is obviously trying to reduce the human error and the gaps, the delay that a person can make. We should understand what is Docker. So Docker is a platform, okay, for developing, shipping, and running your distributed applications. So let's throw some light on what are we currently discussing. So point number 1 is it's open platform, so we can install Docker in any of our machines. It's available to a lot of us. I will also show you some online websites where you need not even take the pressure of downloading it in your system and giving the setup. Okay, and so it's for developing, shipping, and running distributed applications. So these are the 3 keywords that we have to concentrate now. So we know how to develop an application. So whether it is in Java, .NET, or any other application, we know how to develop an application. But what do you mean by shipping? So it means that wherever this application is run, it should have all the dependencies. So it should work well in a different platform. So whatever is required for me to run my application, as it's required in the base system, like the system in which it's developed. So just before the break, we discussed we will be developing our application in our dev environment, but the application will be tested in a staging environment and deployed in a production environment. So the environments are going to be definitely different. So it's not that it's the same place in which it's going to be there throughout. So I should always consider the point that whenever I develop an application, it should be easy for me to ship it. Ship in the sense, take all the dependencies, like from the framework that it needs. For example, from the base framework like .NET framework, ASP.NET framework, or if it is a Spring framework, from all your Java, JDK, the base dependencies that it needs to run. So you can't expect somebody to install Java or JDK or the requirement frameworks for your project to run in your host environment. So that is the meaning of shipping. All the dependencies that it needs to be shipped. Okay. So wherever it is, whether it is your virtual machines or it is in cloud or in another laptop. So the Docker provides the ability to package and run an application in a loosely isolated environment called a container. Because the base foundation of Kubernetes is it's helping us to host a containerized application. So we should understand what is a containerized application. It's not a normal application. There is a difference or a special feature of a containerized application. I just copy the image and put it wherever I want, and that application should get itself executed. That's the meaning of containerized applications. So whenever I try to copy a file or a project from my base machine, from the machine in which it was developed, into a machine where it's like it can be in the cloud. I can have a virtual machine in my AWS, which is EC2 or your Azure virtual machines. And there, if I try to drop my image, it should work fine without even knowing my code or whether it is a .NET or Java or whatever may be the image. It should run by itself. And Docker helps me to pack my application. Okay, so it's a free open source which will help me to create an image for my application. What do I mean by an image? When, see, for example, I double click on PowerPoint or I double click on calculator and my calculator opens, my PowerPoint opens, my Excel opens. Without, I don't even know whether my Excel is written in which language or my calculator is written in which language. I don't know the source code. And I don't know the dependencies which are required to run my PowerPoint or any gaming application or Visual Studio or anything in your machines, Eclipse or whatever it is. So that these are all the images, whatever you open here, like a PowerPoint, a Chrome, or a, whatever other browsers, or you open anything here, these are all the images. And I can open, so these are all the containers of my PowerPoint. The image is called PowerPoint, and these are all the instances of my image. And they are all individual containers. They run parallelly. Okay. So this is what we are trying to say. So Docker is helping me to ship my application to a different environment. So it consists of various things like Docker engine, images, containers, hubs, and others. So you have a place which is or a site called Docker Hub. Like a GitHub, we will have a Docker Hub. Where I can store my images. What do I mean by images? These are my projects which I've created. Okay. and I can just ship them so that they are ready-madely available images. So I can deploy this into my Kubernetes, I can deploy this into my Azure or into any of my container registries, which I'm going to create now. So they are ready-made available images. Okay, and I will also show you how an image is created using a Docker file. So maybe in any one of these applications, I can just stop them because we have seen how an API works and all. So now they need not be in the run mode. And okay. So now I can show you one of my sample Docker file, and which is very, very important for us to understand what is a Docker file. Okay. So this is a .NET project, some API which is trying to create a URL which is giving me the data from some backend. So this is what we need to understand, whether irrespective of .NET or Java, we are trying to fetch some data from the database. It can be list of products, list of customers, list of anything. Now I'm trying to pack this application using my Docker file. So this is a file which you can add it to your project, or like my Visual Studio has an option by which it can be auto-generated. Similar, I think in Eclipse also you have a way by which you can auto-generate your Docker files. And for your Angular projects also, you can have your Visual Studio code. There is a plugin which you can install where your Docker files for your ng serve, like your node things can be automated. So let's just throw a quick light upon what is a Docker file. How is it helping me to create an image? Okay. So the first line of a Docker file says that from this particular site or this particular image, we have to consider this image as the base. That means for my project to run, I need ASP.NET as my base framework. Okay, and it's also creating in my target machine. Like now I'm trying to pack from the source to the target. So source is nothing but the place where my project is developed, and target is the place where it's like it can be any new environment. And normally for staging, we use Docker. Like we can Dockerize our applications and test it whether it is working in your Linux or various OS or various virtual environments. So we are creating a directory which is like a working directory. Work dir means it will create a directory called app and change my directory cd into that directory. Mkdir and cd both together is work dir. So it will change it to that directory, and it is exposing my port numbers, certain port numbers. Like even when you do your AWS EC2 also, you will expose your HTTP or your port numbers so that that particular server's HTTP can be accessed in this port, correct? And then you have your .NET Core. So similarly, ASP.NET, you need an SDK, that is the base JDK or SDK development kit of any language to create for building my applications. Okay, and then I am changing my current directory to my SRC. That means within my app, I will create an SRC folder and move into that. And then I am copying this complete project solution, project file into that. Whatever may be the project name, I'm copying the complete CS project is nothing but the project file, the complete file. And I'm trying to restore. Restore is one of the phase. Like you will try to build, you will try to create your project code, then your build, and then your restore. So you will restore your files and copy everything from the source to the target. And now your working directory will be from the source, you get into the folder of your current directory where you are making everything to be ready for your release. So this is where you are trying to pack your application. So this will not only pack your Docker sample project, it will also pack your base frameworks which are necessary to run and to create this application. And for publishing, what is that's required? So .NET build is the command to build your project. .NET publish is the command to publish your project. Similarly, it will be different according to Angular, ng build and ng serve. And Java, it will be different. And finally, the entry point. So from the base as final, that means from this, we are making that as your final, and the working directory comes here. And I'm copying everything from your current published directory into the current directory in the target machine. From the source machine, we are trying to copy everything into the target machine. Please understand, all these things are happening automatically, provided I write this code here. So I will also show you how it is automated in your Azure. So here I am writing all this code, or maybe I am taking the help of my Visual Studio to do this. And the final entry point is docker sample.dll. So which is like your public static void main, which is the entry point for my project. So this is nothing but my sum file, .dll file. So I'm telling that just execute this, by which all these are set up. So you will be able to see the output of my project. Okay, so this is your Docker file. And if you don't have Docker installed in your local machine, you have, so this particular site will help you to, you should have a Docker login so that it will cross check whether you have a Docker login, and then it will be starting. So this is a 4 hours. You can learn Docker in this. Like for 4 hours, this OS, Linux OS Docker is installed. So you get a VM for 4 hours. Okay. So here you can just check the version of Docker. The version here is 19.03. That's the version. So the client, you will have a Docker daemon running and the Docker client running. So the client version is 19.03. Perfect. So just to check whether in this Linux machine you have Docker or not. And now I can just say Docker pull. There are some official images which I can just show you here. So these are the official images of like Mongo itself, the company Mongo's official image, MariaDB's official image is being installed here. It's been available here. So how do you pull it? You can just say Docker pull Mongo. That's all. So I can just type here and I can say Docker pull a simple hello world. Maybe I can show you here hello world. Okay, Docker pull hello -world. So that's what we have given here. So see, it's trying to pull the image and it's trying to create a container. So this is the ID of your container and it's pulling the latest image from your Docker Hub. So you can just run Docker run vault. So these are this is the output of that project. Like hello world will print a hello world. So something like that. So to try something ambitious, so they have typed these are as the console.writeline. They have printed this. So I don't know in what language hello world was written. I don't know who wrote it, in what kind of OS environment, which version of that particular Java or .NET or Python or PHP they have written. But I'm able to see the output of that particular image. And it's available for me. So the difference between a GitHub and Docker Hub. In GitHub, I'm exposing the source codes. In Docker Hub, I'm just giving you the final packed image. And it is officially given by the respective companies like Node, Mongo, MariaDB, SQL, .NET Framework. You can take your .NET course image. So you remember I showed you a mcr.microsoft.net.com/.net. So this is the image which I'm pulling it in my Docker file. So the official image that my Microsoft gives me, I'm trying to pull it directly. I'm not installing Microsoft.NET in the target machine where my project is going to run. Normally, how do you ensure your project will run? You need all the dependency files. At least you're not going to edit the code, but you need that. Without a .NET SDK, you can't execute a .NET project. Like I need a JVM, a runtime environment to run my Java applications. So that is what is automatically done by using your Docker. It's packing your application to the target machine. And of late, we are getting all the official images from sites like Docker Hub, which is all the companies, like any official, like Node, if you want, you have a Node. So Docker pull Node. Then you can just check whether your Node version is there. So see, it's trying to pull it. See how fast things are happening. It's installing Node within no time, where you do see nowadays your Node is available online, so you can just install it from there. But any of your softwares like MariaDB or SQL Express, where you need the official images, it's available for you in these kind of sites. So you can check your Node. So the two images, the list of images. So Docker image ls, that means the list of images. So now I have a node image, I have a hello world image, which right now I pulled it from my Docker Hub. Like that, I can log into my own login and I can pull my official images, which I have uploaded. So from this, what do I understand? Like how I use a GitHub to transfer my code from across the globe, wherever I go, I need not depend on a machine. I can just push my final images into my Docker Hub, and wherever I go, I can pull them, execute them, like a GitHub or like a Google Drive. So there is one more thing called, so here also you can do. So I'm just giving you some sites because you people were interested to learn Kubernetes. So you have the master node and the client node, and you can just give some commands. So you can, so Minikube, what it is, how to create a single node Kubernetes. So everything is like you need not install things. Actually, what they would have done here is when I start a scenario, this is a VM which is created in a cloud. Okay, and you are given the commands where you can use the cloud machine installed with Kubernetes, and you can just start practicing your commands. You need not have a local Kubernetes available for you, or neither you need a local Oracle VirtualBox or a VM installed in your machine to practice Jenkins or Docker or Kubernetes or whatever it is. But it's all like third party. They are like, you have to take care of clubbing each other, like how Jenkins could pull the code from GitHub. The webhook has to be created by you. Okay, so I'm starting my Jenkins server just to show you the like before opening Azure. I will just show you how in bits and pieces we use Docker, we use Jenkins, everything by ourselves. We have to take care of how to pull the code from your GitHub into Jenkins, and how to create a Docker image. How do you pull the code from the Docker into Jenkins, where we have to take care of all this. But if I create a DevOps project in Azure, as an end user, you will never feel that you are taking care of so many things. Okay. So Jenkins is fully up and running. So I have initialized it in the port number of this. So this is my Jenkins server in which we have a lot of projects. Pipeline is being done, where you can see the pipelines, like how whenever there is a commit that's happening in GitHub, it's automatically having the next steps. See, basically, as I said, why Jenkins? Just to touch upon, give you a insight of what is Jenkins. When, see, till the time you are the owner of your code, you can assure that it works fine. But I said, after you and me integrate the code in the GitHub, there should be somebody, or automatically there should be a build that's happening, and there should be a execution, or the test, an unit test should be done, and then the project should be executed automatically. So to build these steps, that's called pipeline. The various steps are being configured one after the other. So what are the steps that as of now we have discussed is, we have seen, first we are coding, individual developers coding the second is push the code into GitHub so that it's getting integrated. Then what do? You need somebody to build your code after it's been integrated, correct? So building is one of the phase, then testing and executing. The minimum phase I'm talking about. In testing itself, you will have your unit testing, then you will have your integration testing, then you will have your system testing, user acceptance, and after all this only you will try to execute your code. So for example, if it is like Angular applications, we use ng build, or we use our .NET build. And for Java, they use Maven for building your applications. And here you use your ng test or .NET test. And for integration, so all the codes are being done, and they have their integration testing, which can be done through your Visual Studio or various testing servers, MS builds. And your executions finally is taken care by ng serve or .NET run, or Java projects have their execution servers. So these are some of the commands, that the stages which I can execute, so that whenever there is a new push, automatically the integrated code is being built or tested, or integration testing. Then so like that we can have various pipelines for the projects. So this is just so once the pipeline is like whenever the new code is pushed, you can have your this particular part of the code executed, then it will call this and then it will call this. So these are some of your pipelines that's been configured in Jenkins. The same can be directly achieved using your Azure also. Okay. So slowly we are moving into our, so now we have a knowledge about what is an image, how to create an image from our project using your Docker file, and where to store all the images. You have something called Docker Hub where you can officially store all your images, and from there you can pull it into your Azure or Jenkins or all that. You can configure your projects to pull the image from the respective. See, here I am pulling the code from my GitHub. For all this, I'm pulling the code from GitHub. If you open any of the project, the URL will be GitHub URL. When I say configure, I'm not pulling the image. I'm just pulling the code so that when multiple users tries to push their code, still it's in the integration mode. So it's not a final image that's been available. So here I'm trying to pull my code from my GitHub. So now in the before break, we saw how multiple people can push the code into the same URL. So from that URL, I'm trying to pull the code, and here I'm trying to build it. So here I'm trying to run the code directly. Instead, if you say .NET build, then the code will get built. And once this code is built, I'm saying that after the current project is built, I have to run this project. So this is like, it can be the testing phase or the final execution phase. So this is how we create a pipeline manually. And I can also show you a here I'm creating a GitHub hook manually in Jenkins. Why am I showing you all this is you will not feel that you're doing all this in Azure or AWS because it's like one go. Everything is taken care by automatically by them. Okay, so your GitHub is created. I can show you in your GitHub also. I can show you where you can create a hook. Manually, you can create a hook here. So this is the hook which I created through Jenkins, and this is the hook automatically that got created for Azure. Okay, so this is the code where whenever there is a change in this particular GitHub, there will be a GitHub log that will be maintained. Okay, so on this date and this time, whenever there is a change, it will automatically pull the codes and it will execute it. Okay, so this is about Jenkins. So whatever we have learned as bits and pieces, like why Docker, what is Docker, what all we can do in Docker, why Jenkins, what is Jenkins, and what is that we can do in Jenkins. Now we will finally land up in our Azure. So in Azure, you can create a virtual machine. We can create a resource group, some logical apps, and your container registries. So these are all the features or the services which I can use of Azure. So let me just show you a very simple default pipelined project which I took maybe in Jenkins. If I would have to do, then it will take a bit of knowledge that I need to work in Jenkins. Whereas in Azure, I can just create a DevOps starter project. So you can deploy your .NET projects, PHP projects, Node, Java, static website, Python, anything in Azure, Ruby, Go, and C and all. So it's not that only for .NET, but I am starting with my own application, which I have it in my GitHub. So going to the next. So you can also pull the code from Bitbucket, which is an equivalent of GitHub. So I'm authorizing my GitHub. So this will bring me all my apps, all my repositories from my GitHub. Okay, so all my apps are there. Projects from my GitHub is there. I can choose any of my project, which is like my Docker sample itself. Let me take the master branch. See here, there is an option whether my project is Dockerized or not. That means the image will be created or not. And it's up to me to choose whether the project is Dockerized, yes or no. So first, let me not assume that it's Dockerized. Let me just deploy a normal project, non-containerized application project. So I'm going for no. So the runtime environment I am supposed to provide, because if my if my app is Dockerized, it will not even ask all this, because it will take the data from my Docker file. Because there I have said bring in my SDK, bring in my ASP.NET Core and all. But here, if I say no, then I am supposed to provide, whether it is a Java framework or .NET framework and all that. So here, Node.js, Python or PHP, I am supposed to provide. And since it's a core project, I'm going for my next. So it's asking whether you want it as a Windows web app or a Linux web app. So you can deploy it in any of your locations. Okay, these are the data centers in which Azure data machines, clouds are there. So you can choose any of your locations. So I'm trying to deploy my application now in this server, and it will also build me the pipelines. So it's getting deployed. So I'm going to my resource where I'm able to see my project, which is, I'll show you the pipelines also. I will also edit and customize my pipelines. And AWS also, it's almost the same, except the jargons like EC2, and here we call it as a virtual machine, there we call it as EC2. The way the steps might be different, and the way the code commit we try to create in DevOps of AWS, and here we do it in a DevOps started project. So only the jargons might be different, but the steps and everything, the logic, the concept will be the same. So here, if you see, the code is getting, this is the commit ID from Docker, from GitHub we are taking. And the code is already built. So I can just show you a build pipeline. So you could see that from my portal.azure.com, I'm moving into another site called dev.azure.com. So there is a development server. So your dev.azure.com. So from your portal.azure, we are moving into our dev.azure, and the pipelines already, your build is done. So without your intervention, things are happening. You are not even knowing, like just a project you're bringing from GitHub. And automatically you can see the release pipeline also. See, the release pipeline is also successful, where I will be given a URL here. So still, I think. So build is done. Okay, the release is happening, huh? Yeah, the release is still happening. So you can see the steps that's happening during release. We are going to customize this so that we can deploy my application in my Kubernetes. So before that, quickly we will see what is Kubernetes, the architecture and all. So it's creating an app service, and it will deploy my app service. So it's deploying my app service into the machine that is in my cloud. Okay, so once it's deployed, we can use the URL. You will get a URL here, and you can browse to see the output. So all the steps are done. So now by this time you would have got a URL here, the end point in which your application is live, and you people can also browse it. I will put it in the chat window. You can access this. It's a live site like my Amazon or Flipkart. You can even just, so my project, if suppose this is my project, okay, my Docker sample, which I showed you, I think it had, you can check it in your GitHub of Docker sample. I'll tell you. I'm sorry. Docker samples. That was the project I took. Am I right? So I can see what are the codes like. Is there any other controllers? So you have your weather forecast controller. So that's why we accessed our weather forecast. And the Docker file which you saw there. So this is your But we said our app is not Dockerized. I will also create another DevOps project where my app is Dockerized so that these images will be taken and directly it will be deployed. So I can copy this and I'm going to create another DevOps project. There I'm going to make use of my image. The same project I'm taking, but I'm saying my .NET project is Dockerized, where it's giving me an option. You can even deploy it in Kubernetes. Please understand the previous demo where it was not allowing me, asking me where do you want to deploy. Just because my app is containerized. Now I wrote a Docker file where it can get deployed anywhere because it can manage itself. It's a self-contained, self-managed application. It knows what are the dependency files that it needs. So as a DevOps person, I need not bother about having the runtime with me. So I will just go for web app for containers. And you remember the .NET docker sample.dll. So .NET docker sample.dll. I have to just tell them the entry point. Okay, so that is enough for that application to get deployed. Kubernetes, I'll come back. How to deploy it in Kubernetes, I'll shortly come back. So, okay. Next. So you can choose thing. It never asked me whether you want the .NET runtime or Java runtime or what are the files that you need. Nothing it asked. So because it will read everything from my Docker file. So it's getting deployed. So the build is happening. So as such, you can click on the build pipelines. Last time I couldn't show you it happened very fast. So now I'm showing you the build pipeline. See here, directly it built the image. So it checked out and it took the code from your Docker. You remember, so pull, push and all, like the complete, it's taking from the official image of mcr.micro from my Docker hub. The steps which I wrote it in my Docker file is getting executed. So I was explaining all this, like the current directory becomes working directory and it's copying all the files. So build succeeded. So the codes which I wrote in my Docker file, the entry point of that, everything is like getting executed. And finally, it's building an image. If you see in this pipeline, it will never have a word of image. This is the previous project's build pipeline. So here it will be just the steps will be restore your necessary packages, build the project, test the project, publish the project, artifacts. whereas this is my Dockerized. So it's building an image and it is pushing an image. And if you see in the release, that will get deployed in your final target machine. So here what it is doing, it's taking a VM from the cloud and it's trying to run my image. So we don't even know that which machine is that. So the difference between this project is like here I gave the source code, whereas here I gave the image. I asked it to run the image from my source code. I said that the app is Dockerized and I asked it to take the image. So now it will just finish my deployment, and the same way we will be hosting it and check whether. So this is much more easier because once your integration is all done, you can build an image. And after which, if you want further features to be added, you have to create another image. So the image is like the current status of the project. So the image will not get updated as and when you keep integrating the codes. So the current status of the project, you are taking a snapshot, you are taking a pic of it. That's an image. In your VMs cloud, the VMs are not available. So now it's getting a system. See your image, and please make a note, like just an note in the sense, notice this where it's saying SG Docker app ACR, which stands for Azure Container Registry. So it's automatically creating an container registry to store your image. What is a container registry? It's a place where it's a repository of images, like how you have a Docker Hub, which is external. What your Docker Hub does in a third party, your Azure has their own container registry. And inside that, the name of my image is SG Docker app, the second version. The :2 stands for the second build. So SG Docker app is the name of your repos, name of your image. Like how I showed you the name of the lot of images which we have here, my own repositories, I had a lot of images. Similarly, the Docker Hub is an external repository, whereas my Azure has their own internal repositories, which is called Azure Container Registry, ACR. Okay, so now as we know, this is done and I have got my Docker apps browse. So the output as such will not be different. So the end user will not know like what is the difference between the previous and this. But as a developer, as a part of DevOps team, you will have a drastic difference between your deploying your source code and deploying an image. Okay. So what my application did was, I chose what is the runtime environment in which my project needs. I provided as a DevOps person. See here, it should be two different person. My developer is a different person. My DevOps guy is a different person. It need not be the same guy who is going to sit on DevOps. So he provided that this project is .NET framework. He gave the dependencies. The project by itself did not have the packing data. When I gave this project for the first time, I said Docker file is no. So even though it's a part, it is not considered. I said, is your app Dockerized? I said no. So the code which I wrote here is not considered. So as a DevOps person, he was giving me the information that what is the environment which I need to build this project, release this project, the entry point of the project and all he gave. So that is what is the output of this. Where Azure took care from going through the code. It understood that it's a .NET project. This is how it should be built and tested and published and all that. Whereas in the second demo, when I said, is your app Dockerized? I said yes, by which it understood, it went through my Docker file and executed all the steps of my Docker file, and it created an image. And it also has stored this image in an Azure CR, which I can show you here. Come back to this. It would have created a containerized registry. A container registry will be created. I showed you one line there where a container registry will be defaultly created. It's not explicitly shown. Like a sample CR which I created, there will be a container registry which is internally created as a part of this. As a part of your release pipeline, I can show you hopefully. When I deployed, there will be a line which I showed you that see the Docker custom image name. It created an image for me, like how Docker Hub is an external third party. Azure is a Microsoft product. We are not trying to get the image from the Docker Hub. Instead, we are trying to create an image through my code of Docker file, which the developer has written as a part of the code which he pushed through GitHub. Am I making it clear? In Docker Hub also, from where will you?
Right, yeah.
Docker Hub also, it's not a machine which will automatically create an image. Even into Docker Hub, you should use a Docker file to push an image. So instead, I'm not pushing it into Docker Hub. I'm pushing it into my Azure portal itself. The image is getting created into the portal itself. In this SG Docker app, ACR stands for Azure Container Registry. So the equivalent of Docker Hub is ACR in Azure. So this is the place which is a repository of all your images. So it's creating an image called SG Docker app, and the version is. Thank you. Yeah. So now what we are going to do is we are going to introduce our Kubernetes into this. So what is Kubernetes? Why do we need Kubernetes? And what is the role of Kubernetes in deploying my application? So that's what we are going to deal as a complete demo. So let's understand what is Kubernetes. So as of now, we have understood that we have a container management tool. That means a Docker gives me a container. So what is a container? Can one person clarify, like just to check your knowledge? Can an image exist without a container? From your current understanding, just tell me. We saw what is an image. Can an image exist without a container? Like my question is a container within an image or an image within a container? Or what is the relationship between image and container? Simple as that. I can just take this further. So we have it's a container management tool. See, for example, now I have lakhs and lakhs of instances of any application in real time in cloud. You can have multiple containers, correct? So now I hope you know what is a container. So you can have multiple instances of your images running in your, like credit card validation, you take an API. So today morning we were seeing about microservices. So this particular cricket score or credit card or anything, this API can be used by multiple users. That means multiple containers of your API is running live. If I am the owner of the cricket score API, I have deployed it in my live server. There are lakhs and lakhs of containers that are being used by the client who are consuming my API. Correct? So your Kubernetes is required for us to manage my containers. Like if it's 4 PPTs, okay, I can manage. If it's like in real time, lakhs and lakhs of the images, like of this image, if you have lakhs and lakhs of containers, then I need some orchestration tool to manage them. If suppose one PPT doesn't work, one of my container fails due to some reason, like if this gets hanged, so how to kill this, how to reinstantiate this, how to handle the like for example during your big sale day and all, there will be huge request. Like a lot of people would need a calculator application or some other application during some point of time, like my Pokemon Go or your big sale day. So there might be some day by which there will be a huge requirement of that particular API. So after your big sale day of Amazon or Flipkart or whatever it is, then it will come to a normal, whatever it was there before, the on a particular day, the request will be huge, after which it will come back to normal. So who is responsible for scaling up my environment and scaling down back to the normal? So these are some of the reasons why we need an orchestration tool which will be doing all this. Okay, so when I have a need where I can scale up and scale down, so during the weekends, there will be huge requests to my Amazon, Flipkart, Diwali time and all that. But after which it will have a normal kind of request. So the scaling up of my services, okay, and then orchestration. So once a container is there, so I create if there is a problem with that container, then automatically the self-healing, it will your Kubernetes will kill the container, reinstantiate the container with the necessary informations, and your EXCs, automatic pin backing is done. So where the data has to be deployed, from where the external data, the volume has to be taken, all that is taken care by Kubernetes. When we are dealing up with large volume of data, it's not practically possible for my DevOps guys to sit and manage the infrastructure, to sit and install all the softwares that's required, to sit and take care of my monitor my all my containers and my nodes and pods. So that is where we go for my Kubernetes, and the equivalent of Kubernetes is Docker Swarm. So Docker is, again, as you know, it's a tool for creating an image and a container, and you have the concept of Docker Swarm, which is same as Kubernetes. But the point is, this has more reach than Docker Swarm. Okay. So in your Kubernetes, ideally speaking, we will have a master node and some worker nodes. So minimum of one master and one worker node is minimum. So you can have as many worker nodes as you want. And so this master node will communicate to the slave node or the client node or the worker node, and which will have pods. So what are these pods? So a pod, like that particular circle which I showed you within a node, contains, every pod contains an application container. So please understand, an app, this is the container. So an image is run here. So it can have a single container or multiple containers like this. and then a storage resource, because it can't store all your data within the container, which will make the container very heavy. So the storage informations will be stored in external part, and then IP address, so that that particular pod can be referenced. So this is what is a pod. A pod contains ideally the container of your app, then your storage resource, and your IP addresses. Okay. And now coming back to this diagram. Okay. So now I can have multiple pods within every node, and every pod can have multiple containers, and which is all managed by your master node. So how do they manage? So you have an API which is talking to your API server, which is nothing but it has an API server. It allows the communication with another server or another worker node, another node to node communication. And it is the front end of your Kubernetes, and it exposes API for almost every operation. So we know what is API. It provides an endpoint. If you want to do this, this is the endpoint. And the users, the management devices, and the command line interfaces all talk to the API server to interact with the Kubernetes cluster. So ultimately, we say this is a cluster of nodes, because that's what we understood. No, it's a cluster of nodes, and one master is managing, orchestrating. Okay, now you do this, you do this, you do this. As a team lead, he is trying to tell the job of each and every worker, and once they are done with their job, he is taking care of managing them. Okay, now your task is done, you go and do the next task. So the rescheduling of tasks. So the same is done by your Kubernetes server. The orchestration is done among the nodes by your master node. So here you have the scheduler, the server, and the control manager, and all your secrets and configuration information is stored in your external volume called etcd. So this is an external volume in which you store your, see, you can't keep storing your secret passwords, which we will be creating. A secret password we need to create. And all those details, we can't have it as a part of your server. So we are storing it in an external domain. So this is my master node and my worker nodes. Within my worker nodes, I will have a kube proxy and a kubelet. Okay. So these are my worker nodes heart, which takes care of creation of the pods, how the containers are being maintained and all that, and the containers are taken care by my Docker, because Docker is the place where my images are stored. So for Kubernetes, Docker is a must because it deals with containerized application only. Kubernetes cannot handle non-containerized applications. Okay. So when we were talking about our secrets, so every container will have a secret and a configuration maps. So this tells, like, obviously you will have some configuration details, no? Like it's easy for us to change only that particular place, the configuration details, so that any changes in the code or in the server, it's enough if you go and make the modification in your configuration files. So these are the secrets and the configuration files which are maintained externally, not as a part of your container. So let me show you. So before creating your DevOps project where you're going to do all this, an image and all that, one small concept which are called YAML. So yet another markup language. So that's your full form of YAML. And this YAML file, in the structure, just to give an idea, it's not like JSON. It has your the name and your details. So it's not like JSON, which is like your key value pair. JSON file, the API output was in the form of JSON. I showed you. The output of an URL endpoint was in the form of JSON, whereas this is the YAML structure. So it tells you like the name and the value, the key and the value in this format. So if I want to deploy my application in Kubernetes, I need to have a YAML file. I think this has. Okay. Okay, just give me 1 minute. Okay. So this is called a YAML file, and you need to understand what is this YAML, like how to build an image. I need a Docker file to deploy an containerized application. I need a YAML file. Okay, so this is very important. So here I tell the name of my deployment of how the metadata. So the metadata is the information about itself. So this file will be used in my release pipeline, which will have my secret keys. I'm going to generate this secret key right now in AKS, Azure Kubernetes Service, by which I'm going to create a container registry with this name, like CD Docker, or you create a container registry and please feel free to edit this. Vice versa is fine. But because I have loaded this application in my GitHub, then again I have to do a git commit and git push and all. Just to avoid all that, I have created I have to create a container registry with this name, and the repos is nothing but the image. The name of my image is normally colloquially called as repos, the repository. So this is the name of my image, and the build ID I always give latest because it will keep changing. So this is the file which I'm going to. So how I showed you in my previous example, it created its own container registry. Now I'm going to create my container registry with this name. Okay. And I'm going to create a secret file for this container registry. What is a secret file? A secret file or a secret key is something like I am an authorized user to push my code, push my image into this container registry. Like for example, I collaborated, I invited somebody to push code into my GitHub. Similarly, if I want to push this image into this container registry, then I need to have a authorization. That is what I'm going to create. So I have made a note of all the steps that you might require. So I'm going to do all these steps. Okay. So first step is I'm going to create a container registry. So I was telling that the container registry would have got created, and here you can see that image. I was searching for a container registry, within that app I was searching. So this is your image, and the build ID was 2 if I'm not wrong. Yeah, so you can see that. So like that, I'm going to create my own container registry now. And as I told already, I'm going to just replicate this name. The resource group, I can use something. So I'm using the available zone, and the SKU I'm using basic or standard, anything should be fine. It says it's not there. Okay, so maybe I'll refresh and I'll get it. Because if it's already there, that's fine. So I'm going to create a Kubernetes service. So I'm adding a new cluster. Okay, so obviously there will be a master node and 2 client nodes, worker nodes. So let me give it an RG1 and let me create it as, so the Kubernetes cluster, given name it as KC, just for your naming conventions. And as I told you, minimum the number of nodes, the node count you can choose, it's 3. If you want to have multiple nodes, you can keep adding it. It's running for the validations, just checking whether the sponsorship and all that is fine. So it will take a long time because Kubernetes, it has to prepare your VMs. As I said, 3 VMs are to be prepared, and then it need to take care of your networks, the IP addresses and all that. So orchestration involves from the scratch, it's trying to get the nodes and everything is happening in the cloud. So it will take a bit of time. So let it do. In the meantime, I will just go back to my container registry if it's created, because I need, or else this time if it's not there, we will go for. And I have again, I have to edit my GitHub. That's the reason I was a bit hesitant. I'm not able to delete it also. I'm trying to delete the container registry because it's not got properly created, neither it's allowing me to create something new with that name. Okay, no problem. I'll just I will use my sample CR. Okay, this is already created a container registry. So now I have to go to my GitHub, and maybe I have to change my YAML. Okay, because without which I will not be able to, it will get deployed in a different place. So this is my, I'll cross check whether it is the same project. Yeah. Yeah. Okay, so here I'll open my Docker sample config.yaml, and instead of cd, I'm editing it here itself because from GitHub is where I'm going to take. So what was a new samples here? So you can even copy from here. Okay. Rest all is the same, sample cr.azure.cr.io. Sample cr.azure.cr.io. So I have to commit. Okay. So please verify whether it has got changed. So now I'm fine to go. So here for my access keys, I should first of all enable my admin user. And if you see in my GitHub, the secret name which I have given in my file is dsconfigsn. Okay, I'm going to create a secret key with this name for this username and for this password. Okay, so how to do that? So we have created a container registry, which is sample CR. We have created a Kubernetes service. Maybe I'll cross check whether the deployment is done finally. So your Kubernetes services. So your HWKC is already ready. Okay, the process is finished. Now open your Cloud Shell, and or if you have a PowerShell in your local system, just a storage, temporary storage to work with your commands. So it will hardly take 1 minute. Just a temporary storage where all your commands can be executed. Where I'm going to just use this step. So to create the secret key. So step number 1 is done. Step number 2 is done. I'm going to create a secret key in my Azure shell prompt. That first I'm adding a storage account. Okay, so it's getting created. The next is I'm going to issue this command where the resource group name is RG1, which I would have already created, and the name of my KS, I have created it as HWKC. If you want, you can create it with any name. Okay, yeah, it's created. So the first is I'm going to issue this. It will give me my prompt, command prompt. Yes. So paste. So I'm getting the credentials of this resource group and this Kubernetes cluster. So it's merged with the current context. And here, please understand, if you install Kubernetes in your local machine, then you have to configure. We were talking about some configuration files and my secrets, no? That So all this I'm trying to do, but it is always done, taken care by my Azure Kubernetes, AKS. And now what is that I'm going to do? I'm going to use my kubectl command, which is using to create a secret key with the name of dsconfig.sn. This name and the name what I typed in my code should be same. So vice versa you can do. Whether if you're creating with that, please update it here, or if you're whatever name you have it here, please try it there. And the name of my Docker here, I have to change this to sample CR. The name of my server, and the username will be different now. So I will copy paste the username which I showed you in my container registry. So switch to your container registry. And go to my access keys. The username, and the password. And your subscription email ID. So these are the details that's required. The first is the name of the secret key. So what am I trying to say is, henceforth in every place I will not give that this is the container registry and this is the username and this is the password and this is my mail ID. So instead I'm just mapping all this with the secret key. So I'm going to copy this and paste it. If you really want to be a pro in Kubernetes, you should be playing well with your commands. But if you have decided to work with Azure or AWS, you always have the option of your UI. So that's why even in my PPTs, I would have said either through command prompts or through your UIs, you can work with your kubectl command from your Cloud Shell or through UI. But if you are installing it in the local system, or if you are doing it with your without the like your Jenkins or Docker as a third party, if you are doing just Kubernetes, you need to be very good in your commands. Or else with your browser, it's fine. Your Azure or AWS, it's fine. So now it says my secret key is created with the name of dsconfig.sn. Very good. So now the next step which we can do is, so I already have a YAML file in my Visual Studio, and the properties of that YAML file should be copy always. That means what I'm trying to say is, whenever there is a change in this YAML, it should be immediately updated in my thing. In my deployment, till my build pipeline should be affected, your release pipeline. So that's why the properties is always changed. And so directly I changed in the GitHub, so that will not be a problem. So now I'm going to create a DevOps project. So what we did just few minutes before, I'm going to do it and show it to you how it's deployed. So the final steps, I'm going to create DevOps project. because I have stored it in the name of learnings. So I have changed it here. So I have to pull that code. Is your app Dockerized? No, because I'm going to do it during my pipeline. Okay, so here I don't bother my Docker file which my developer has written. I'm going to show you how to edit your build pipeline and Dockerize your app. So I'm going to give a no, and I can tell that it's a .NET Core project and your Windows web app. So it's ready. So now the project will go for a normal default build and release. But what I'm going to do is I'm going to edit my build and introduce Docker in that. And with that image, I'm going to deploy that image into my Kubernetes. So it's like few things we are going to edit. So I'm going to edit my pipeline. So let the default build happen, default release happen. I'm not bothered. So here in this stage, the first change is I don't want a Visual Studio in my Windows because it will take a long time. So I will change this into an Ubuntu VM. And then what will I do is I will add a and here I will remove the zip because I want my YAML file to be acting as the artifact. So I don't want this because my image should be taken from the YAML file. So what I'm going to do is I'm going to introduce Docker here, which will create my image. Okay. And I'm going to say in which container registry it should deploy. So you can take it from your Docker Hub. So this was the question somebody asked. Did we take the image from Docker Hub? No. We are going to put the image in my own container registry, which is called sample CR, which I created it. So sample CR is the name of my container registry in which I'm going to check whether the image is getting created. Okay, I can customize. And the name I can give it as something like SCN1. So you can choose your Docker Hub also from here. But as I said, it's an equivalent as Azure Container Registry, which is a native compatible one with Azure. So the name of your container repository should be the same. So please Docker sample repos, because this is what my YAML file will search. So it's better I make it available here. And the Docker file is created with your build. Okay. So save and queue. All my changes are done. So I'm going to save and queue. For which commit ID? So for this commit ID. So the pipeline is not getting properly created because of the version is wrong. So we will once again check the version. So Ubuntu is given. For your build and push, I think there was an error. Okay, I copied the other one. I'm sorry. I copied this. Some zero. It started with 0. This is the commit ID of my Azure CR. So the commit ID was not matching. I copied from my previous project. So it's running now. So let me show you the Docker is not even taken. My Docker file also is not now considered. I have introduced Docker as by editing my pipeline. So not even from my code, my Docker file itself is not necessary. The developer need not write a Docker file. As a DevOps person, I can pull my third party. See, it's taking from my Docker. So this is where I'm creating an image. The output of this is an image, which I am putting it into my YAML file, because already the configuration I have told in my YAML file that the image will be available in this container registry with this name. So now I will take that image and edit my release pipeline and deploy it in my Kubernetes. So it's all these steps are written automatically in my edit pipeline just by adding that word Docker. So this shows the power of Docker, which is able to create my image during the deployment, during your pipelines. So it's successful. So you can quickly go and check here your container registry, whether that repos is done or not. So in your sample CR, you can go and check your repository. And now it should have a repository with the name of Docker sample repos. Okay. So here, now I'm going to edit my release pipeline. So I've got my image. Already there are two releases that's happening. I'm going to edit my pipeline where I'm going to disable the default. I don't want it to be deployed in my app service. Instead, I'm going to add a new stage where I'm going to bring my Kubernetes here. So here I'm going to now say the data, the subscription. What is a subscription? The cluster, into which cluster. You remember I created an AKS. So into which cluster, and the default one I will just and use your credentials where your configuration secret file will be used, and the name can be anything. And the command here is going to be kubectl create. I'm going to create a particular thing, and your configurations, this is where you will take your YAML file. And in your secrets, so it will show me my sample CR, which belongs to this sponsor, and I have to type my secret key so that I'm saying that I'm an authorized user. So the Kubernetes server will store all the secret and the configuration files in an external thing. So I'm giving a save. So deployment customized. So your release 3 is initialized. So only one step where I'm trying to take the image and put it in my Kubernetes cluster. So only one step I'm trying to do it here. So kubectl create. So here already my 3 nodes are waiting. So my master node will take this containerization, because one of my container, my image is there. It's trying to take one container and execute it in my Kubernetes node, so that I get an IP address, and when I click on that external point, it should be able to. So everything is working fine. Go back to your Kubernetes so it should give me yes. Now in my, so to see the dashboard, I have few commands. Quickly I'll execute it. So I customized my release build and release pipeline. So I should be an admin to see the dashboard. So see, actually the site is hosted. I can show you that, but I wanted to show you the dashboard, for which I should be an administrator of my Kubernetes. So the dashboard is the exact place where you can understand the services, like why Kubernetes. So that's the reason I had all this ready. I'm binding my admin to the role where I can see my dashboard, and I'm getting my secrets. That is the password to log in as admin to see the dashboard. The site is hosted already. It's available in this. But for us, as I told you, there is nothing special to see the output. We need to see the this is my admin's username, and I want to see the complete password of that. Okay. So now I have to give this by browsing. So it will open my dashboard. It will ask me the token. I have to give the token which I copied right now. So it's saying it's failed. There should be green color. Okay, the pods is not created. But your kubectl is created successfully. So this is the endpoint. This is a VM that your Kubernetes is. This is the new machine. So in fact, I can show you the image got successfully created. It's creating an external point and it's creating your virtual nodes. So this is the dashboard. So the number of pods. So I can check. It's failed to pull the image. Okay, somewhere the image is not. So I can rectify this, but I hope within this awareness, like a workshop, I have. So it's saying that the failed to pull the image. So maybe somewhere the name is wrong. Sample cr.azure. So I showed you the image also here. So the secret key has the access permission also. So the image with the build, okay. I forgot to give latest. It's the build ID of 5. So that's the reason I'm pulling the latest, but the ID is missing. No, so that's the reason. So I have to go and edit my pipeline again. I should have changed here. The build ID was 5, but it will keep changing. So statically, we can't give 5, no? So in my release pipeline, I have to. So now this is running. It's cute. So let it go. In the meantime, I will just edit my release pipeline, where I will add one more task of kubectl. Because already my drop folder is there. No, I need to now delete it before I create it. So So let me check whether my build is successful. Yeah. So kubectl. So that's why I edited it. So whatever was already there, it has to delete it and then edit it or create it. So release 5. It will first delete whatever was there and then it will create. So it will go and delete the already YAML file that's created, because for the first time it will work, then you have to manually delete it. So the Docker sample hyphen deployment file deleted, so that when your creates it, it'll be working fine. So if this is fine, working fine, I think just that latest was missing. That's the reason you can see the errors by your. So this is the dashboard of Kubernetes. So you can have your machines, virtual nodes. You can manage your complete the orchestration through this. So your secret keys are maintained, your tokens of admins are maintained. So as a infra person also, you can take care of your Kubernetes installation, the server nodes, the worker nodes and all that. And as a DevOps guy also, you can 100% work. So this task is pending. So everything is done. Going back. So now it's green in color. That means my service is deployed. So I can go back to my, and here I can show you in my repositories also the latest. So the build should be latest. So it's refreshing. See, if this is there, then it can pull it. So my so you people can also access, and using that IP also, whatever is there given to me here, that IP also I can access this. For that IP only, this name is given. Okay. So are we clear with Kubernetes and how to host an application in Kubernetes?